We all know who.
You don't know, just shut up and mute your mic now.
Yeah, please guys, mute your mic. Okay, so today we have to move or on our next very main chapter, and here in this chapter we will learn or study our CPU or control processing unit architecture, right? It is one of the very we can say known architecture which if we forget then maybe we will miss a lot of the things. Uh, sorry, Neo, did you know that what is MITM attack? Sorry, not MITM attack. Uh, there is an attack, I don't know its name, in which we used to send a lot of packets, right? So that the server will crash.
We both know, bro, about this attack.
Oh, DDoS attack.
DOS attack.
DDoS attack, right? Actually, DDoS attack. Yes, DDoS attack only perform just because of the limitations of CPU, right? If we move to the mechanical part of our computer, then we can say that it only happens just because of our CPUs. The CPU are not able to take that much load at the server level. Like so, we will today we will study our whole architecture, CPU architecture. So yeah, here we go. Okay, firstly, I want Neo and Bicho. Please, can you tell me a single thing? Means, can you describe computer in your own terms? Because I just wanted to confirm that whether you means I know that you have already you all already know, but I just wanted to confirm it.
Then, like in my language, computer is a thing like a processing unit in which many processes are going on the like on the same time. Uh, like CPU, like you are asking about CPU, whole
No, no,
CPU
no.
or just the processor?
I'm not asking about CPU or processor. I'm asking about computer. What do you mean by computer? A basic definition. How can you define a computer to a 10th class student?
Computer is an electronic device which we use to introduce the things.
Okay, Neo.
Might be the same definition for
Your voice is not clear.
you. Hello.
Yeah, yeah. Now it's better. Okay.
Maybe it like the same definition.
Don't please means just try to copy paste means sorry. Don't try to copy paste. Try to give your own one.
Then look. In my language, like computer is a device.
Yeah.
Okay,
Yeah.
in which we can process different kinds of things. The input we give, according to the input, it gives the output like this.
Okay. Anything else?
Hello.
Anything else?
Hmm.
Hello.
Yes. Ethan.
Two more members are missing.
Yeah, I know that I have already messaged to both of them, and they will reply that both will join maybe after 10 or 20 minutes. We can't wait
Okay.
for them because both of them are already behind us, right?
Okay. Okay.
Okay, let's continue our CPU architecture. Sorry, CPU architecture. I think Bicho and Neo already knows a lot of things. Okay, so chapter 3, CPU architecture. As we all know that it is just a book's definition, CPU is the brain of the computer. It executes instruction, process data, and control the entire system. Right? What is its purpose? Its purpose is just simply execute programs, perform calculations, control hardware, coordinate data movement. The main part comes here is that the component of CPU, the main component of CPU. There are three main component of CPU, which is ALU, also known as arithmetic logic operator. The another one is control unit, and the next one is register. Right? I have already told you all of them that IPO will work everywhere. Right? Input, process, output. Here, memory, CPU, and output device. This is the means this can be the cycle, what we should say, which works on the behalf of IPU, right? So firstly, we will understand that what ALU actually is, right? The main one of the main component of CPU.
Bro, listen.
Yeah,
What's the full form of IPO?
input, process, output.
I was like initial public offering. Input, process, output.
Yeah, we have already read about that framework or cycle, input, process, output, in our earlier class and in our earlier classes. Right?
Yeah, I remember. Thank you.
Yeah, okay. So we are moving to ALU, arithmetic logic operator. The ALU performs all the mathematical and logical operations. Okay, I have a question here with all of you. If we remove ALU, then can we able to perform any other task or not?
Task like
For example, creating new VMs, virtual machines, and rendering
no.
images, etc.
No.
Why?
Because ALU used to calculate all the things of computer.
Yeah, so it is basically used for calculations, na? Right?
Yes.
But we don't need any calculation.
But maybe in the terms of binary, computer used to calculate.
Yeah, okay, okay. Then you got it? Yeah, okay.
Am I right or wrong?
Yeah, you are right, you are right. In terms, if we need to change it into the binary, then we need to perform calculations, right? So, ALU perform all the mathematical and logical operations. Operations, for example, arithmetic operations, which include addition, subtraction, division, multiplication. Logical, for example, and, or, XOR. Okay, we haven't take a deep look on this logical operator. We will take after completing this ALU, right? And then comparison operator, you all know that bit operations, for example, left shift, right shift, rotate. Did you know these bit operations? It is nothing but just take a look on this, right? We want to shift one bit toward left side, right? So we just input one value that we have to add one more off bit here, and this will shift out all the values towards left, right? This is only a basic example of bit operation, sorry, right? You got ALU. Okay, now we are moving to our next main component of CPU, which is CU, control unit. The control unit manages and coordinate every operation inside CPU, right? It doesn't calculate, it controls, right? The upper one, the ALU unit, the arithmetic logic unit used to calculate, but the control unit used to controls. Think of it like a manager of a factory, right? What is the responsibility of CU? So it's fetch instructions, decode instruction, tell ALU that what to do. Means it can be said at the head of whole CPU. Tell memory what to read or what to write, and control data flow. For example, let's take example. We have to add A and add B, right? So what it will does, what how CU will give instruction, right? It firstly read our instruction, right? That we have said we have to add A and then add B. Then it understand that okay, the user wants to add two different terms. Then it load A because we have mentioned A first, right? Then it load A, then it load B, and then it tells ALU that you have to add them, and then it shows us the result. Firstly it stores, then it shows, right? Now we are moving to registers. It is also one of the very main component of our CPU. Registers are the smallest and fastest memory inside the CPU. Okay, I think I wanted to ask a simple question, but I have already wrote the answer here. So registers are the smallest and fastest memory inside the CPU. So the task will control with two memories, first RAM and then the registers, which is the smallest and special type of memory inside the CPU. Accessing RAM is slow for tasks to go from CPU and then access the memory from RAM. So it have to travel a lot of distance, right? In terms of micro level. But registers are extremely fast just because it don't have the command or the data don't need to travel that much space. CPU always tries to work using registers, right? And CPU doesn't need RAM anymore, right? But because it only use registers. But for our system to work, it needs RAM, right? There are few common types of registers here. Just wait for a minute. Okay, so there are few more type of registers. First is program counter, which is also known as PC, which stores address of next instruction, right? Means if CPU, if we give some instruction to our machine, it will send to CPU, and if we give another instruction, then it will also send to CPU, right? But the another instruction will be stored at register in form of PC, program counter, right? Instruction register, these stores the current instruction. Okay, may I know a single thing that why we need PC if we have IR? I think that we all need only IR, right? Because it stores the current instructions. But why we need PC? Can any of you?
What's your question?
We have two type of registers in our CPU, right? PC and
Okay.
IR, right? And here PC stores the next upcoming instruction which needs to execute. Yeah.
चटनी नहीं खा रहा ना तुम?
खाएंगा.
So which needs to execute after the present one, and IR. Okay, IR stores the current instructions which CPU performs, right? So why we need PC if we have IR? My question is that.
I think I think it calculates the what will be our next instruction to it. That's why
But
we need PC.
Okay. Anybody else? What is the main reason?
actually, to be honest, I would not able to understand the question because right now I'm busy somewhere. So can you please repeat the question once again?
Okay, okay. I just want.
Maybe due to speed.
Yeah.
Maybe due to speed and all.
Yeah. You get it. Due to speed. I
Oh,
just
great.
because if the CPU already know that what will be the upcoming task, then it can process more fast, right? That's why we need program counter. If you have studied about neural compression, then there also this plays an important role. Scientists used to research more about it. Okay. Next type of register is accumulator. It stores intermediate arithmetic results, right? The next one is memory address register, which is also named as MAR. It uh, sorry, stores memory address to execute. Means at what memory address we have to execute our task. For example, if MAR is 500, means read memory location at 500. It may be the location in the motherboard or maybe in the RAM, right? And MAR defines that we have the RAM have to work at that part, right? At the location 500. Then we have MDR, which is memory data register, which stores stores data being transferred, means and the data which have to be transferred. And then we have stack pointer, which points top of the stack. For example, function calls. Actually, we don't uh, need to move too much inside them. I just introduce all of these in front of you so that you have a basic idea that how many things are there, right? And then we have flag register, which store flags, right? There are kind of different kind of flags. For example, zero flag, carry flag, overflow flag, negative flag. Now, uh, if we talk about zero flag, then okay, let me tell you a single thing that if the CPU performs any calculation and on the basis of result, flag register shows that flag, right? For example, if our answer is negative, right, then it will show the negative flag. If our answer is positive, then it will show the carry flag, right? And if our answer is 0, for example, here after 5 minus 5 we got 0 flag, right? So the 0 flag will become 1 because 1 means on, right? Hope you got all these registers. You need not to remember each of them, right? Yeah, okay. So now we are moving to clock. Okay, so the clock synchronize every operation inside the CPU. It is just basically the heartbeat, right? It produces regular electric impulse. Every CPU operation happens on these pulses. Means just like you hope you have seen the heartbeats, right? On on the what we should say, at the top of at the peak of every spike, right? CPU performs operation for at every tick. I mean tick here means spike, right? It fetch, decode, execute, and access memory, right? Means these are all the kind of tasks which CPU performs. So CPU is just perform uh, with the help of clock rate, right? Means see like that. If we play music, right, then we need to be in a particular rhythm, which we also known as tempo, right? Because if we lose that rhythm, then maybe we will not able to make our beat with the another musician which played. Hope you got that example, right? Did you understand? Yeah. Ethan and you, did you got it? Okay, I'm just uh, telling that. Just wait. Okay, I'm just telling that. Uh, let you are a musician, right? If you need to play, you let that you play guitar and I play harmonium and you play something else, right? Piano. So to maintain the rhythm, right, we need to play in a particular speed, right? Which and that speed is also known as tempo, right? To measure, to maintain our rhythm, we need to play our music, play our instruments in a particular speed, at a particular speed, right? That speed is just a clock rate here, right? Nothing else. CPU need to perform task in a measured way, in a measured timing. So the technical thing which here the what the replacement of tempo is clock speed or clock rate here, right? Did you got it right now, Ethan? Yeah. Okay. Now clock rate, it measured in hertz, kilohertz, megahertz, and gigahertz, petahertz, terahertz, and so on and so on. Right? 3 hertz, 3 gigahertz means 3 billion clock cycles per second. The per p of per is removing here, removed from here. Okay, so yeah, there is a point to keep remember that higher clock rate doesn't always mean faster CPU, right? Because performance also depends on cache, pipeline, IPC instructions per cycle, core count, branch prediction, and memory latency. We will understand pipeline and cache in depth in our upcoming sessions, right? Hope that you got the basic knowledge that what a clock or a clock rate actually is. Did you got it? Okay, new.
Yep, got it.
Okay. So now we are moving to our next topic, which is fetch, decode, and execute cycle. CPU works in term of this cycle, right? For example, our computer works in IPO cycle, input, process, output. CPU works in fetch, decode, execute cycle. So this is the CPU's continuous working loop. It firstly fetch, then decode it. It firstly fetch the task which user give it to does, and then it decode it, then it execute, and then it repeat, right? For example, the RAPL loop, which you have, I think, studied in when you have studied about Python, that whenever we type Python at our terminal, then we send inside, the RAPL loop, right? So fetch means, okay, step first is fetch. uh, CPU fetches the instruction from RAM. Then decode means control unit understand instruction, that what the instruction actually is. Then ALU or another execution unit perform the operations, right? Maybe the ALU or maybe the another execution unit, right? Both of the things are can perform actions, right? They will perform actions or execute tasks, and then it store result, and then it move again into the at the first step, which is fetch. It again fetch new task, then decode it, then execute it, then again it repeats it, right? Also here stores working, but it is just store means it is not seen, right? It is not visible. Result goes to registers, cache, and RAM, right? The results which are stored here will want all of these three things. Now, yeah, I think that we should do some practical experiment. I also haven't did these on my VMware, on my Linux machine. Should we do it or not? I need your suggestions, bro. Should we do it or not?
We can do it today, bro. Like, you can only show the practicals today. We will tomorrow continue.
The practicals are not too much. Means here there are a lot of practical, but I don't want all of them to tell you, because if I tell all of them, then it might be that you get confused. Today we are just taking these three things, right? Watching CPU information, view CPU details, and watch CPU uses, like, because I haven't installed GDB on my Linux. GDB is Did you know that what GDP actually is?
I don't know, bro.
Yeah, so GDP is, you can say, a kind of software or simulator which helps you to uh, memorize or take a deep look on your CPU, right? I haven't
Could you
confused.
explain briefly what's a GDP?
Yeah,
Could you explain briefly what is GDP?
GDP is actually a software, right? Okay, take a single thing in a consideration, right? That CPU perform millions of, I mean, not millions, yeah, millions of calculations per second, right? So if we try to see that which calculation is controlled or which calculation is processed by CPU at the particular time, right? So we are not able to see without GDP, right? Because if we went, then might be in the nanosecond or millisecond that the task will change, right? So if we need to take a look separately with the help with respect to the process, then we need GDP. What GDP does? GDP stops our CPU, right? GDP create another layer on our CPU. Then our task flow from firstly RAM, then RAM to GDP. So what GDP does? GDP blocks it. GDP don't allow it to went. GDP don't allow it to move to CPU, right? Then when we say tell GDP that okay, GDP now you have to give pass that instruction, that particular instruction. So it will pass a single instruction. Otherwise, it will, if there is no GDP layer, then it will execute millions of tasks in a particular second. Did you now got the purpose of GDP?
Yes.
Yeah. Okay. Just okay. So what's our first practical? Yeah, it's about LS CPU. Watching the information of my CPU. Okay, let's try what happens here. Okay, it lists all the information about my CPU. For example, CPU operation mode, it's 32-bit and 64-bit, right? My CPU operation mode is twice, means you can also tell that x86 or underscore 64 bits, right? 64-bit architecture, right? My CPU has architecture of x86 underscore 64-bit, and then address size 45-bit physically. Actually, we need to understand, means we need to read more in depth about CPU to understand it, what does actually mean for us, right? If you want, then we will read in depth, but I don't think so that we need that much depth, because we are not going to does any kind of semiconductor work here, right? Byte order, little a, and then I don't know what is it. Online CPU list, vendor ID. Yeah, so it is the particular vendor which is genuine Intel. I have Intel Core i5 in my laptop. That's why it's genuine Intel. It is the vendor ID. Then its model name is 13 Gen Intel R4. It is, yeah, here's the information. i5 13 Gen 450HX, which we only need to whenever somebody asks that what's your processor, what's your CPU is, we only need to we only tell them this information. i5 13 450HX. CPU family, just wait, what is information FPU? Sorry, I can't. Where it is? I don't know why it don't show us course. I think that I'm doing some mistake. Okay, for right now, I just need to show you that it will tell you this much information. If you can understand it, very good. I can't understand because I haven't taken that much deep look. And I also don't want you to take a deep look because it will basically unnecessary time waste if you unless until you don't have to master in CPU, right? Now, okay, CPU details. We have. I think that I wrote something wrong here. Cat proc CPU info. Okay, cat proc CPU info. Slash proc slash info. I think this is also the same. It tells us, yeah, here it is the information which I talking about the processor. Maybe the core is also available here. Stepping available. This is two flags. Can you take a look on these? These are just the flags which was what I should say generated by our CPU, right? Mm, okay, CPU vendor ID, core ID one. Okay, yeah, I have given two cores to my Kali machine, right? So here I can see that the CPU core is 2. Did you know that what core actually is? The core is means you can say that in the architecture image here. Just wait. In the architecture image, you can see that it is a means when we combine ALU, FPU, it is different thing. We need not to understand it depth in depth, and then register and then control. Right? When we combine
Hello,
register, yeah,
someone joined up like meet. Check it.
yeah, she's a new member.
Okay, got it. No worries.
Yeah, she's a new member. We will actually her level is not means her depth level is not till the level where we are, right? So if I talking or if I taught at the level of her, then you might get bored. So what I just want to finish up this CPU architecture first today, and then I have to cover all the remaining chapters to her, right? So here, if we take a look, then when we say combined form, right? Core is a combined form of CU, ALU, and registers. But in real life, means at the machine level, I think that you need not to go there. Actually, I don't know that how to simplify it more, right? So that you don't get confused with the more of technical terms.
Bro, if you don't know to how to simplify this in English, you can explain it in Hindi also.
No, no, the main problem is not English Hindi, right? I can explain in English. The main problem is about the glossary or the technical terms, right? Also, I forget some of the technical terms. If I tell you about their work, then might be that you don't connect with it. Okay, we can try one more thing. Top and edge top. There it is. Okay, to show CPU usage. Yes, it is very good thing. Here you can actually take a look on a lot of tasks. You might seen that the process are updated very fastly here. CPU usage, virtual, and process ID, user.
So I have an idea.
Yeah,
I have an idea.
yeah, please.
Like if you don't know how to brief something more deeply, you can search it on ChatGPT. Maybe we can understand their language.
Yeah, okay, I will try that approach next time, right?
Okay, thanks.
Yeah, okay. So top is the command. Means it is the one of the more very useful command till right now for us, right? Because we don't able to interpret this much this language, but this is the very useful information for us which we can interpret, right? Right now it's timing, right? It matches my Kali machine timing up to 10 minutes. It shows us the I don't think so that it shows us the information about all the 10 minutes, because in 10 minutes it performs a lot of the activities, but it don't load it here. What is the load? Okay, you know what is zombie process? Here.
I know.
No, okay, we will talk it about later. So it performs 2 to 7 tasks totally, total, right? And two of them are running. It is uh, talking about the major uh, part of the major task which we have given to, right? Not the sub process of it, because the sub process are there are a huge number of sub processes. But if we take a broader look, then means it's just in a normal terms, right? It is talking about the normal terms, 2 to 7 tasks according to us, not according to CPU. One of them is running right now. 2 to 5 is sleeping, means they are on the sleep mode, neither shut down, neither stopped, or not dead. Also, I don't think so that we need to take a look on them. Hope that you actually got the thing that what I actually wanted to show you, right? And that you can actually see all of these information. Tomorrow I will configure GDB on my Kali machine, right? So we will try to explore it as much as we can, right? Where it is. Okay, did you got it? Okay, now there are some questions if you all got it for today, and after these question discussions we will over today, right? Because I have to take another class as well, and try to brainstorm on these questions, right? Means we will try to discuss one after one by one with each of you, right? Please try to serve your views in front of all of our members, right? So our first question is, why are register faster than RAM? I think we have already answered it. Ethan, got it? Actually, I am asking. Yeah, you know that. You know that. I am asking to Ethan. Ethan, please give me the answer of this one. Right? Why are registers faster than RAM? Bro,
Hello,
yeah. Try.
hello.
Yeah,
My voice are clear. My voice is clear.
yeah. Your voice is clear.
So why registers are faster than RAM?
Yeah, you have already told that.
So it do mainly the more mathematical part of or
Yeah, try.
what?
We need to try, right?
Mainly the register do the
Try slowly. Try slowly.
uh, like it give a more read and write speed to the RAM.
Hmm. As compared to RAM, you should say, right? Because register and RAM both are different. Okay, means you tried best. Okay, either Bicho Bro or Neo. Please describe it.
In my
System
language, like
store, a register store already some amount of information. Because of that, it is faster than RAM.
mm,
No.
basically in my language, like registers are already built in the CPU. That's why it is faster than RAM.
Yes, registers are already built into the RAM. And Bicho Bro said that it already stores information. So, no, that are another thing, right? That was not the main reason for it. Okay, now what is the difference between ALU and CU? We have already discussed about it. Who wanted to give its answer?
ALU used for arithmetic performance, and CU used to control that performance.
Yeah, control that process. Okay. What?
Actually, I have used the wrong but performance. Maybe it was the process or what we can say.
Yeah. Okay. So, what happens during the fetch, decode, execute cycle? Okay, let's don't take a look on this question, right? We will delete it from here. What is the role of program counter? Did you remember it? PC. Any of you?
It addresses the next like task of CPU.
The next task which CPU needs, right? Process counter stores address of the next instruction. Hope you all got it right. Okay, may I know, did any of you used to create notes during the class? Because I think that I moved too fast, so it might be that you don't get enough time for note it, right? If anybody did it, then please tell me. I will stop there. So, what is the purpose of flag register? Yeah, it is good question. What is the purpose of flag register?
Bro, sorry for interruption. May I leave the class? Actually, I have to go somewhere else
Yeah,
right
yeah.
now.
You can leave. You can leave.
Okay, thank you.
Yes, Neo Bro or Eden. Can any of you tell me that what is the purpose of flag register? Neo?
just wait a second, man. Just wait a second.
Okay. I'm waiting. I'm waiting.
Basically, like the flag registers tells the CPU like what is the current process is going on.
You are close. You are close.
Mm, I don't know then. Like,
Okay. Let me tell you.
mm,
If uh, value is negative, right? Then which flag
mm.
will turn, and what will its state at the time when we receive the negative value?
I think zero flag.
No. It's negative flag, right? Negative flag will become one when we have negative value. Got it? Our CPU only understand the binary language, right? So flag registers are the ones which indirectly shows to the CPU that either the value is negative, or it is zero, or it is positive, or it is taken by carry, right? Only that register which is more associated with the current value will become one, and all of them will become zero, right? Hope you got it. The Hope you got the purpose of flag registers. Yeah, okay. Nathan got it?
Can you explain it one more time?
Okay. And you already know that CPU understand the binary language, right? It only understand the binary code. Just wait. Okay, it only understands the binary code. So if a output of a calculations come as negative, right, then how it will show to the CPU that the value is negative, because it not able to understand the minus sign. So what it will do, it will take a negative flag and then make it one, means on the negative flag. With when it on the negative flag, the CPU get the sign that okay, the value is negative. Now did you got it? Yeah, okay. Does a higher clock speed always mean a better performance? Yes, actually, I also don't know the answer of this question, right? I want to brainstorm on that one. Please, I want your views on this question. Does a higher clock speed always mean a better performance? New and Eden. Also, our new member, I think that sh when she joined, no, she can also answer it. No, she can't answer. Okay. Uh, Neo and Eden, please try to brainstorm a bit. Right? Does a higher clock speed always mean better performance, and why?
Hmm. Because of the speed of the if the clock speed of a CPU is higher than the processing capacity of the resistors uh, and all the components are very high. That's why the speed is much faster than compared to other CPUs.
No, I'm not asking that why the speed is higher, speed is faster. I'm asking that does a higher clock speed or the higher clock rate actually means better performance of a CPU or not? And if you think that yes, the higher clock speed or the higher clock rate means a better performance, then why?
I think it's no.
It's no, it should be no.
Yeah,
Okay, Neo, what's your perspective?
Maybe maybe slow, but not that much.
So you also wanted to go with no, right?
Yep, we can say that.
New member, if you got my what yeah, if you got my question, then please try to answer it. It is the simple logic question. Did you got the question? Yeah, so please serve your perspective in front of us. What did you think? Does the higher clock speed or the higher clock rate means the better performance or not? Did you get please.
I understand the question, but I'm not able to answer it. I don't know
Okay,
about
means
it.
okay. You don't got these terms, right? Clock rate and clock speed. Okay.
Yes.
According to me, a higher clock speed is means according to my perspective, it should be yes, right? Because if a CPU performs multi-million task at a second instead of million, then we don't feel lag, right? It will always gives us the better performance from the earlier one. I don't know that whether my answer is purely appropriate or not, but if I'm wrong, then I need proof. Okay. So, hope you got my answer right. I'm with yes. Now moving to our next question. Why can't the CPU execute instructions directly from hard disk? Yeah, I think that this question answers the uses of RAM as well. Why can't the CPU execute instructions directly from hard disk? Anybody wanted to answer it? Either new or Eden?
Because the speed of the hard disk is too slow than the RAM and CPU.
Yeah. Okay, okay. Means it's just a game of speed, right? Okay, let's move to the next question. How do the control unit ALU register work together to execute an instruction? Right. I have already told you that, right? Please. How do the control unit ALU and register work together to execute an instruction? Then you remember it? Ethan, Neo, any of you? I think that you need to remind a thing that we have studied the cycle here. Fetch, decode, and repeat. Fetch, decode, execute, and repeat. Right. This is the only cycle which helps all these three ALU, CU, and the registers to work together. Right. Hope you got it. Did I need to elaborate it more? If anybody have doubt, okay, Ethan don't got it right. So okay, you got it. Okay, okay, okay. I need not to elaborate it more. Okay, so I want to wrap up today's session with one line revision. CPU, which executes instruction and control the programs. Sorry, control the computer. ALU performs arithmetic, logical comparison, and bitwise operations. CU, fetch, decode, coordinate, instructions, execution, right? Register, ultra fast CPU, or we can say ultra fast RAM, which is placed under the CPU storage for instruction, address, data, and result. Clock, it synchronizes CPU operations using clock cycle. It takes all the tasks into a rhythm, and then fetch, decode, and execute. It is the cycle on which all the three here ALU, CU, and register works together. Hope that you all understand the purpose of today's class and the whole material which we have read today. If you have any doubt, then please ask. If no, then we will wrap it up today.